In particle motion, questions regarding a particle are given. A particle could be an individual or a moving object. It is important to know position, velocity, and acceleration equations, and be able to move between them by differentiating and integrating. It is important to know that position's derivative is velocity, and velocity's derivative is acceleration. Other things to keep in mind are that speed is the absolute value of velocity. If velocity and acceleration have the same sign, the speed is increasing. And if velocity and acceleration have different signs, the speed is decreasing. To find the total distance traveled at a velocity, you must take the antiderivative of that velocity from point A to point B.
A saxophonist marches along a straight line with a velocity in yards per second. Velocity equals 2t squared minus 8t plus 6 when t is between 0 and 18. Part A. Graph the velocity function over the interval 0 to 18. Determine when the saxophonist moves in the positive direction and when she moves in the negative direction. First, solve by factoring, then set equal to 0. Make a number line, then plug the numbers in between the zeros back into the factored form to determine if it is positive or negative. Part B. Find the displacement of the saxophonist in yards on the time intervals 0 to 1, 1 to 3, and 0 to 3. Interpret these results. Displacement is position B minus position A equals integral of velocity from A to B. Plug in the function, find the antiderivative, and solve. Do the same process for interval 1 to 3. Over the integral 0 to 3, the displacement is 8 over 3 plus negative 8 over 3 equals 0, which means the saxophonist returns to the starting point after the first 3 seconds. Part C. For the first 3 seconds, find the distance traveled. From Part B, we can deduce that the total distance traveled by the saxophonist. On the interval 0 to 1, the distance traveled is 8 over 3 yards. On the interval 1 to 3, the distance traveled is also 8 over 3 yards. Therefore, the distance traveled on 0 to 3 is 16 over 3 yards.
Stacy throws a flag straight up into the air, reaching a height of position equals 10t minus 2t squared after t seconds. Assume the flag's initial position is s equals 0, which is the point at which the center of mass of the flag leaves Stacy's hands. So our first question is, how high does the flag go? So in order to find how high, we're going to have to find the derivative of the position equation to find velocity. Because when we find the velocity, it'll give us the time it takes for the flag to reach its maximum height. When you find the derivative of position, you'll find that it is negative 4t plus 10. You'll set that equal to 0 in order to solve for time, and it will give you negative 10 over negative 4, which produces 2.5 seconds, and that is your time. So to find how high the flag will reach, you'll plug in that time into the position equation, and it'll produce 12.5 feet. Part B asks, what is the velocity of the flag when it is 12 feet above Stacy, which is position equals 0? So to solve for this, you must set the equation, the position equation, equal to 0, and add 12 to the end because this is going to be your y value, because this is the height that the flag reaches. You will now factor out the equation and take out the negative 2, and then you can factor it into t plus 6 and t minus 1. This means that t equals negative 6 and t equals 1. When you plug 1 into the velocity equation we got earlier, this will give you 6 feet per second, and that is our answer. Part C asks, when does Stacy catch the flag? This is the time it takes for the flag to go up and then back down into Stacy's hands. This should be easy because we already got the time it takes for the flag to reach its maximum height in part A, which was 2.5 seconds. It'll take the same amount of time to go up as it does to come back down, so we'll just take this time, 2.5 seconds, and multiply it by 2, and that'll give us 5 seconds.